All right, should be live. Let's get the chat working. If this will work, we'll see. All right, cool. Just need to get myself situated. All right. It's been a while since I streamed, actually. Been about 2 weeks. Maybe a bit longer than 2 weeks. Interesting. I'm surprised this should work. This is weird. So that works. This does not. Hey, how's it going? Welcome to the stream. All right, let's see. Oh, it does work. Interesting. It's just I'm not getting error output here on the side. That's odd. Yeah, so I'm still working on graphics stuff, which is fun. Seems like it never ends. Okay, so if we look at this music's a little loud, actually, at least on my end. Mostly code architecture. I need to fix some stuff with the shader compiler that I'm writing. Because I'm still working on implementing a metal backend for my rendering layer, and it's just been a project that hasn't. It's just never ending. There's like corner case after corner case that I didn't consider. Yeah, I guess I can give some context because I don't know how many people, if you were in the last stream or have any idea what I'm working on, but I have basically my engine. I have my own shader language that basically you write your shaders in. So you write them in this little sort of higher level shader language, and then at build time, depending on which graphics backend I have, like set for the build. It generates either like GLSL for OpenGL or HLSL for DirectX. And then Metal has its own shading language that it has to use, obviously. And they're all pretty much the same thing, like fundamentally. But obviously the syntax of the language is different. And what I wasn't accounting for in Metal, or I just haven't accounted for it yet, is how the instance buffer data gets, like, I guess, packed into the vertex data struct. So like if we look at GLSL, when you have an instance buffer, you basically have, let's see, where is this? I guess it's right here. You kind of have these things in like global namespace, I guess. And you specify a layout. But in HLSL, it's a struct. And you have to like append it to the bottom of a struct for the instance data. In Metal, I've just been doing 2 structs. Hey, how's it going? Welcome to the stream. So I basically need to get this here, this stuff down into this struct here, like I'm doing for HLSL. So I need to look at how I do that in HLSL, because I actually don't remember what I did for that. Because if I go on Mac, I tried to compile this shader, and now it's telling me that it doesn't know what this is, this instance thing. So yeah, it just doesn't know what that is, because this should be part of the input format rather than the instance. But let's see what I do for DirectX. So I guess I can just type token type. Let's just see what I do. Instance maybe. I would start, well, actually, that's a good question. I'm kind of biased, I think. I would say start with C, which contradicts what Oscar said. I think starting with C, at least like for a couple months, for a couple months, because like C is it basically like forces you to know how memory works, and just like low level concepts. And then C++, you can abstract a lot of that away, so you don't actually have to worry about it. But it's good to like know how that stuff works at like an intuitive level, I think is really important. And that's kind of how I did it, is I learned C first, and then I kind of understood how like memory works and pointers and all of that, and like types, and like the alignment of types matters as well for things. Okay, so what am I doing? I'm just scrolling around. I need to see what I do, because I have like this sort of hacky code gen here. Yeah, here we go. I have a comment. So this is in generate structure. Let's see. Yeah, so I need this in my Metal backend as well. Down here, it appears. What's this semantic thing? I don't even use this. This should be like... semantic. And then... let's see. Structure members. Do I not call that? Well, yeah, okay. You don't. You can't nest the struct. So what I'm saying is, I need to manually append those things into the struct. Okay, this is annoying because I do this differently in my metal backend. Oh, this is unfortunate. What is this? So I've already abstracted this, so I need to abstract this in metal as well. All right. Yeah, because the way my shader compiler works is well, it's like I guess a typical compiler, is that I parse my language and I build the syntax tree with these nodes. And then depending on the back end, like the output shader language, I basically just generate code as like a text file, obviously. And I need to refactor this to be more like the GLSL or the HLSL version. Okay, so let's do that. So we need this, basically. Actually, it might just be easier to copy this and just modify it to be like what I had. Okay, so if we... Can I open two of these? Yes, I can. Fortunately, it's going to be on a different screen because I need to look side by side for this. I just need to refactor this slightly. All right, so let's see. Less yapping, more programming. What's this semantics reset thing? I don't even know what this does. Semantics reset. Oh, this is for the count. Yeah, I don't need to worry about that. I just need to look at this again really quick to see. Oh, actually, I will need this. Potentially. Okay, actually, I am going to skip doing this because this is easier to just reason about this on the fly. So we do need this lambda. Yeah, compilers are pretty tough. Thankfully, I'm not doing like a full compiler. Like I don't really do much error checking because ultimately I'm passing this through to like the actual metal compiler in like GLSL compiler. So I just need to generate from my shader language just valid translated code. And then it's like up to the actual, you know, metal compiler to give me these error messages if I'm doing something stupid. So that makes my life a little easier, but it's still tough because it's like when you do these like shader translation things, you need to like design your abstract shader language, like your common shader language, to sort of be like maximally verbose in how much information it has. So that like, because there's some quirks that like HLSL expect and like GLSL expects, like semantics, like these semantics on here. So if you don't have that information baked into like your base source shader, then like there's no way of deriving it. So it's kind of tricky because it's hard to like know what all of those things are until you actually start, you know, writing more code, more back-end code, and it's like, wait a minute, I need this information. Okay, so let's see. Slang. Yeah, I'm basically doing what slang does. Slang, slang. Okay, so I need all of that. I need this up here. I'm gonna be doing a lot of jumping back and forth because this is like essentially the same code, just slightly different in certain ways. We need all of this, I believe. First, last. Do I need this? Personally, I'm not a huge fan of the syntax of slang because like for my engine, I don't really need the full feature set of like every shader like option. But slang like is a general purpose, you know, meant to be used widely type of thing. So, I mean, it's cool though. All right, let me see. I'm a little scatterbrained at the moment, if you can't tell. So we need to do this loop, of course. What is this CPU struct flag? Do I use that here? I don't even do that. Let's see. Hey, how's it going? Welcome back. Been a couple weeks. Let's see. So I do need the type name. Yeah. Okay. So we have our structure, and then we begin the body. And then, yeah, we add the member. We do this now, basically. And I think in theory that should just work, except the slot count needs to be out here. What was that? Was that a uint? Is what a blocker? Sorry, I'm my brain is heavy in this refactor right now. Okay, let me see. What does our code look like? Let's see, metal. Here we go. Yeah, so now we've combined this. This isn't a blocker for me, no. I'm just working on... I'm just working through this because this is just one of the many problems I need to fix that I'm planning on fixing today. Okay, so this didn't work fully though because it's not doing the attribute. So why did that happen? And this didn't work either. Okay, I see why, I think. It's my own shader language to metal, basically. So I actually have this translation layer for GLSL, HLSL, and today I'm working on the metal translation. But I finished the HLSL one, so this works already. And like I can demonstrate that in a little bit. Right now I have my compiles busted because I'm generating all the source code at once, or all the output shaders at once, just because it's easier to work like that. All right, so where am I using this prefix thing? No, I'm not using SPIR-V cross. It's because and the reason for that isn't because I just like want to avoid SPIR-V cross. It's that my shader language does more than just it does more than just translation. So I actually use my shader language to generate some boilerplate C++ code as well for the engine to use, to make it easier to like actually work with shaders in the engine, like game code. Like I can demonstrate this here. Let me fix this just so I can I can demonstrate this slightly, because right now everything's broken, so it doesn't look like anything works. 1 second. Let me just re-enable this compilation, so it should work still. Let me go to a more interesting project. So here's like here's one of my little test projects, or my demo project. It's a globe. So that was rendering with DirectX. And then OpenGL. I can switch to OpenGL. And now it's running OpenGL. So the actual shader code for that, the globe, is in this project up here. Runtime shaders. So here's like the shader for the atmosphere. And then this is in my shader language. And then from this, I translate to, in this case, GLSL, right? So like you could use SPIR-V cross to do this in theory, right? You just take the SPIR-V like bytecode and then decompile it back to GLSL or HLSL. But I also do stuff with like the uniform buffer. So I have the concept of a uniform buffer in my shader language. And the cool thing is like I can just easily in the shader code just define one of these things. Like here we go. Actually, let me go to a different shader. That'll make it easier. So like up here in my fragment shader for like the composite stage of my render pipeline, I can just add a new buffer here, like uniforms test, right? And I can add like a color to this. And then in my fragment shader, I can just take this thing in, color, multiply the color by that, you know, color, actually, let's do like color. Can't type today. Right, so if I build this and then go into main here, wherever I draw, I don't know, right here, I guess, I can just immediately access this thing. Uniforms test.color. I can like set this to red. If I just run this, that doesn't work because what happened? I love when I give it a demonstration, it doesn't work. Oh, I didn't upload it. Yeah, 1 second. I forgot to actually commit this thing. So yeah, now it's red. And the cool thing is, it's like, it's just so easy to do that. Like I can create like a static color up here, color, hook it up to like a console variable. And now it's like I have, actually I didn't link this. Let's make this red again. So like now I can go color and just immediately change stuff just like really easily. Let's say like, hey, what if I want a new field in this thing? You know, let's see, composite. We want like transparency. Not even sure if this will work, to be honest. I mean, it surely could be, right? There's a million ways to skin the cat here, but it's just a cool feature. And I have a bunch of other stuff too, like that's just the uniforms, but also defining vertex formats works the same exact way. It's like to define a vertex format and just use it in a vertex buffer, you just have to edit it in one spot, and I immediately have a CPU accessible struct. Well, it depends on how you view the maintenance cost, because this is like you just write this once and it will work kind of thing. And that's been my experience so far, is like I'm not really changing my GLSL and HLSL code since I've written it. So I think it's actually been worthwhile to do this. But yeah, it's certainly a project. Let me undo all this though. Composite. All right, anyway, back to metal. And then how to get into C++. You just have to write C++, I guess. I know it's a pretty bad answer. Just start with small projects and then work your way up, really. Oh yeah, sorry, I missed that question. Yeah, it is an extension that I have for my engine. So all the stuff on the bottom that you're seeing is my own extension that basically drives my engine. And like the way my engine works is it is driven by the command line inherently. Like if I open this up, like open up a terminal here. Oh, typo. Like I can compile the project from the terminal. And that was a full compile, by the way, of the entire engine and the assets that you just saw. If I do clean, this is how long it takes to build the entire engine. Super fast. I'm proud of that because C++ compile times are usually really bad. But yeah, so my VS Code plugin just basically generates these commands. And no, it's not going to be a commercial engine. It's purely a hobby project for me. I just have no intention, like what you said with the maintenance cost. that would be genuine if I made this a commercial project, because people would actually rely on this to work. And yeah, I can't guarantee that it works in every single edge case. And I just have no interest in supporting that in any official like capacity. No, it's not a Unity build. It's actually just full on compile. And I can prove it. I can prove it if we go to like this project. See the output folder on the left here doesn't exist, right? And we click build and run. So we can see it built 57 translation units for the actual runtime, and then 39 for the build tool as well. And it took 1.5 seconds. C++ is just a low-level language. So, like, yeah, it's UI rendering. But yeah, C++ is just a low-level language that lets you build abstractions over low-level concepts, I guess. Is like kind of the strongest point of C++. Is it's like almost as low as you can go while still having abstractions that are actually useful. It's pretty much the same as HLSL actually. So like you can see, like here I just use well, let me see, shader. I just use mul. So all right, so let me turn this back on. I'm getting blinded by the sun through like the gap in my my blinds right now. It keeps hitting my eyes. Hard to see the screen. Okay, what was I doing? GFX. Yeah, so I have this little flag where if I turn this on, it just compiles every version of the shader. Hopefully I'm not missing questions. It's a Unity build. And yeah, it's not a Unity build. I just don't use the... what just happened? I don't include from the standard library. And I do some other things to keep the actual like translation unit, just raw code size, small. So like the actual translation is really fast, or the actual compilation is really fast, just because it's not compiling unnecessary code. Okay, so instance. I'm in the wrong project. Okay, so this is correct. Now it just needs these attributes, which I'm surprised aren't being generated. I guess this should be type. There we go. I don't use AI too much for code. I just don't trust AI to give me code that's actually good. So I don't really like using it for actual like code generation. I mean, I'll ask it. Oh, what's going on here? We have a gap in here as well. I'll ask it for like help finding documentation on stuff or like explaining concepts at like a higher level. But the actual code stuff I don't use too often. Okay, let's see. So I have 2 commas, so I need to factor that as well. Where do I skip? The token type, maybe? Okay, I need this as well. Actually, I just need this whole function. Fortunately, there is a bit of duplicated code between these backends. What's happening? Okay, so that, in theory, should... Oh, it did not. Interesting. Oh, it did work. Yeah, so that did this. So now it's using the actual vertex struct input and then finding the correct one of these. And then this didn't work again, which is broke. That literally was just working like 2 seconds ago. Let's see. Oh, it does not like that. I think my build tool is actually seg faulting, which is funny. Let's find out what's causing that. Because look, it's not even generating all of my shader files. Okay, let's figure out what's causing that. The only semantics I require is the, or for vertex inputs, no. For the output, you need to specify a position because it needs to know that for like, let me jump to a shader. So like, let's just go to one that's easy. Yeah, so the way I have it set up is you have like a vertex input, and you just specify, you know, what are the members of that. And then I have this packed as flag, which is like an optional. It basically tells my C++ code gen how to actually generate the CPU struct for this thing. And then when you're specifying like the input bindings, because like for instance with a UV coordinate, you could use like a in like a uint 16 to represent your UV coordinates. And that's smaller than using 2 floats, because you're probably not going to have texture coordinates like with as much, like you don't need as much precision in your texture coordinates since you're working on like sampling image data, pixel data. So like this lets me basically just specify that this is a packed vertex format. But for the output and input for the fragment stage, you need the position semantic. Yeah, exactly, with color too. Yeah, I use VS Code for everything. And the font is Iosevka. I can type it in the chat, actually. Just so it's easy to find. But yeah, I did have semantics in my language up until a few weeks ago, actually. And then I basically realized that it's completely unnecessary to have them, because the only ones that actually matter are like well, in HLSL, they're the system value semantics. So you have SV position, and like this is a required one. But these other ones, I just like auto generate these, because the only thing that matters about them is that they match between like your vertex output and your fragment input. Or I guess this is a bad example because it's down here. It's like so long as they match between stages, that's all that really matters. And like metal doesn't even have semantics. It just has like these attributes. And then the position one, again, is like SV position in DirectX. And HLSL, yeah, doesn't have, or GLSL doesn't have them except for, you know, GL position, GL frag chord. So, yeah, all right. So I need to figure out why, why is my build tool seg faulting? Let's turn ASAN on and see what's happening. Oh, it's not even catching an ASAN. I might just be in an infinite loop here. Okay, yeah, here we go. So we are heap use after free. Interesting. Doesn't like this. And this should be, oh, it was, seg faulting HLSL actually. Okay. Heap use after free. One, two, three, four. Line 1, 2, 3, 4. Yeah, it doesn't like this line. So is this just, which of these are freed? Could be a lot of things actually. Is that always happening between all projects? Yeah, that one's fine. So it's just this one. So this is fine because that would assert if that was bad. It could be this. Unfortunately, I can't easily attach the debugger to my build tool. So we have to do some printf debugging here to figure out what's happening. Well, I could attach the debuggers. Just there's like takes in different arguments. Okay, so it doesn't like doesn't like this. So which of these? So this thing is not actually... because Vulkan doesn't run natively on Mac. That's the answer. Vulkan can run on Mac if you use the Molten VK emulator, essentially. It just emulates Vulkan through like with metal under the hood. But at that point, you're not natively running Vulkan on Mac because Mac doesn't have drivers for it. Yeah, basically it's a translation layer, which is fine, right? And like a lot of projects do use it, but I just think it's more fun to just write graphics code. So yeah, and I actually don't support Vulkan yet in my engine, so it's not implemented yet. It shows up in the list, but it doesn't actually do anything. I only have DirectX and OpenGL and Metal partially implemented. So this is not valid. This is not a valid instance format. .node. I'm curious where this is getting freed, because it's a use after free, so I must be freeing this somewhere. Is it referencing an instance format from a different shader, maybe? I go live every couple of weeks, I guess. I have a very infrequent schedule. I'll use metal, yeah. Okay, I am just going to ignore this for now, actually, because it's not super important, but I will have to leave it to do. I think I know what's happening. I think it's referencing an instance format from a different shader, and I'm not keeping that alive in memory, basically. So although this pointer is not null, the actual thing it points to doesn't exist anymore. So it's, yeah, trying to read memory that's not free anymore. And I guess I could figure that out. So where do I set this? Find all references. Let's see. So here. So I set this here, and then yeah, it's certainly a behemoth. It's really annoying because plus plus C. Yeah, exactly. Pre-increment, right? It's annoying because you would wish it would all just converge onto one standard by now. And it was like heading that direction. You know, you had Vulkan that's kind of like was spearheading the effort to created cross-platform, standardized. They did SPIR-V, standardized bytecode. But then Apple comes along and they're like, wait a minute, we want our own ecosystem. We're not going to support OpenGL anymore. We're not going to support Vulkan. We're going to create our own brand new graphics API and shader bytecode. So if you want to do anything on the Apple ecosystem, you're forced to do Metal essentially, or use a translation layer and lose some performance. And now you have a new abstraction layer beneath your code that you don't have control over. And then, yeah, of course, Windows has DirectX. Thankfully, Windows also, supports Vulkan drivers. And Linux as well does Vulkan. So it's getting better, but it's and not only that, you have different versions of these APIs that have different support across the suite of graphics cards. Yeah, or they might have just written a Metal graphics backend. It's not that much work, depending on how you've architected your code base to support Metal. I actually think of the low-level APIs, Vulkan, Metal, DirectX 12. I actually like Metal. I just like the API. But yeah, okay, so this is getting freed. Let's see. I'm just gonna print this thing, print this pointer. So we set this here. Classic printf debugging here. So we set that, and then where do we clean the AST? Compiler. Okay, so yeah, exactly. This was my fear. So I figured the problem. So yeah, like I said, it's each of these little compile shaders is a new shader compile invocation, and that pointer is being set in this one, and then the next shader that compiles is trying to read that pointer, because my shader languages can share vertex formats and instance formats. Now the solution could be to just not share them. Yeah, and that's true as well. Yeah, because you need the... No, I don't know that channel either. Okay, so let's see. How can I fix this in an easy way? Instead of using a pointer to the node, is there a... I could just use the ID, I guess. Do I need the node? I kind of do need the node, don't I? I could store a copy of it, I guess. Let me see. Yeah, I should have foreseen this happening. So what do I need from the node? Oh, I actually do use the node. So which shader is this? I'm going to show off. I'm going to actually demonstrate the problem. So let's just print the path here. Yeah, so this shader here specifies this instance format, this instance test struct thing. And then, wait, I'm compiling this thing. me see. Maybe this isn't a problem. This is a fake problem. Yeah, okay, I see what's happening. Okay, disregard everything I said. This is happening because I'm compiling these shaders multiple times in the same context, which I didn't actually design my system to do. I kind of hacked that together. And that's just so I can like quickly see all of the output types. Unfortunately, it's causing a seg fault here because it wasn't designed to do that. I still think this can fail though. So I should fix this. Because the situation I was thinking about, let me see if I can just make a quick test of that. Let's go into this project. Metal. Yeah, so we have like, it's a quick shader. So we have like an instance. So if we do something like this, where they're like that, we have to put this in the list. Delete all this other stuff. Just to demonstrate the compilation failing. Okay, so this should compile still once I turn this off. What is happening? All right, so that shader, this is just like a test to see if this actually is a problem. Is here, output, generated shaders. So here's the output for that. So we have our packed instance, per instance data here. So if I create an identical shader, just with a new name, why didn't that copy? Copy. So now we have like a shader that's like copied, but maybe it makes the color green. I think this is going to cause a problem. Yeah, so what happened? I'll put in missing semantics. Yeah, okay, so if we look at this output here, it failed. Pretty much. And the reason this failed, I believe, if I turn back on address sanitizer, it didn't catch it, interestingly enough. Like if I name this something different, like example 2, I think this will work again. Yeah, see, it works again because it's seeing it as a unique instance type, whereas before I was trying to combine them. I should just turn that off because that's honestly not a feature I want for the instance formats. Nice. Yeah, I had a I had a crazy problem with Linux a few months ago. I had Arch Linux installed, and I was doing like like a system-wide update of everything, like a sudo pacman syu or whatever the command is. And during the update, it like segfaulted. So like I was getting like the cascade of updates in the log or whatever, the terminal, and then it dropped a seg fault. And then and then my operating system, my install was completely bricked. After that happened, I couldn't boot anymore. Like my Linux just self-destructed doing an update, and I've kind of given up on Linux since then. I need to reinstall it, or fix my install, which just means reinstalling it because it's not going to be salvageable. But that was a first. I've never seen a seg fault in like a system update. Okay, so I need to fix this. This is going to be a pain in the ass, though, actually. How should I do this? So this was kind of hacky to begin with. Well, I guess if I'm reusing a vertex format, it should exist in the shader I'm currently like compiling, right? It's just pointing to the one that was freed from the last time. So I think it's just a matter of where I assign this node thing. Like node, where I assign this isn't being called because I assume this is early outing somewhere. Like, do I early out up here? Yeah, here we go. Yeah, I probably messed something up too. Because I have limited Linux experience. So right now I have Debian installed now. I have it on like a separate computer, but I have Debian. So because I do support Linux natively as one of my platforms. I've given up on Arch ever since that incident. Okay, so I early out here, so this never gets set. So this should be set somewhere. I think we just need to set this up here, actually. I'm going to set this in both places. This should update the node, I believe. So let me fix that, fix that. Hey, there we go. I think that worked. Hey, there we go. Yeah. I also have some weird problem with the computer I have Linux installed on is well, the computer is fine, but I have a motherboard. I have like an Asus motherboard. And it's like has some weird bugs with how the Linux like bootloader works. Or I don't know all the terminology here. I'm just kind of half-assing it. But there's some weird thing with my Asus motherboard where it doesn't detect it in like the boot list when you're in the BIOS. And there's like some weird hack I had to do like while installing the operating system to get the Asus motherboard to actually recognize it as like a bootable drive or something. And I've always suspected that my motherboard is just like potentially causing these problems I'm having. So I really need to find a motherboard that's actually, yeah, maybe. I don't know. I went down the rabbit hole of like looking, like going through the you know, the forums online trying to find someone else who had the same problem as me. And there was like one thread that exactly matched, you know, my motherboard, my problems. And the one post actually got it to work for me, but I should just get a different motherboard. Okay, so that should fix that problem. So if we finally go back to what we were doing. This is probably not, this is not very interesting stream content because I'm just like, nothing's happening. Okay, here we go. We're getting errors that seem somewhat reasonable now. Okay, these are, yeah, these are actually errors I expect to see. Yeah, there we go. Okay. So we have this now, and then we have this actually references this, which is nice. So the last piece of this is that I have a trailing comma here because I think it's skipping it's thinking that the instance buffer is here as a parameter, but it's actually not. But I'm generating a comma regardless. So we need to do that. Metal. So where do I generate these things? Yeah, it's generating one for this. Interesting. Let's see. So I think this should remove that. Oh, I've actually added a comma. What? Oh, there's one here. There we go. Now it's gone. Nice. All right, so let's see. Let us. Let's see. Let's commit these. Then if we go over to my Mac here, grab these changes. I'll be surprised if this actually works right away. Yeah. Use of undeclared identifier. So what's the problem? Wait, why did it do that? Yeah, this is not true. Hey, there we go. Oh, I'm actually surprised that this looks kind of correct. So my metal backend is not finished yet, so the viewport stuff isn't working yet. But that's easy to, well, that's on the to-do list. But the fact that that actually looked kind of reasonable is exciting. Let me fix the viewport though. Okay, it's not perfect. Depth testing doesn't work, it appears. Well, it does work. Okay, but what isn't working is the snow. Doesn't work. Ooh, and this doesn't work either. this does work. Depth testing is turned off. Okay, so I think there's a problem with drawing instanced data without a vertex buffer. I need to fix that because I should be seeing snow particles. Like, there isn't any snow. If I go in OpenGL, it's probably hard to see in the stream, but like, there's instanced snow, and that's not working on metal. So I guess the question is it actually not working, or does it just appear to not be working because of some other issue? So let's find out. There we go. Exactly. Missing vertex descriptor buffer binding at index 1. So yeah, it just doesn't have draw instance indexed. Yeah, so it's expecting a vertex buffer to be bound, which it doesn't have, which in the code here happens here. Why am I not a doctor? I don't think I'd be a good doctor. I think programming is, I like programming because it's very precise, you know? It's like everything you do is just like, if you write code, the computer will do exactly what you tell it to do. But if you're a doctor, like, I'm answering this question seriously, kind of, because it's fun. Like if you're a doctor, the biology is not precise, right? It's like statistical, whether things will work or not, you know? Like, oh, how long will it take to heal? I don't know. Statistically, it takes people like 6 weeks to recover from something like this. It's like you can't be precise, really. And that would annoy me. All right, so I actually don't know specifically what it's mad about here. Well, I know generally what it's mad about. See, maybe this is something I use AI for. Is Metal without a vertex buffer. Do I still need to bind one? Yeah, that's that's also very true. Allows vertex shaders with no vertex buffer. Then you can completely skip binding any vertex buffer. Yeah. Then you can issue draw primitives. Vertex start. Okay, but what's this error then? Bind a dummy buffer or a real one. Remove that layout from your vertex descriptor. Okay, so what am I generating here? Yeah, that'd be fun, reading something like that. Starting from like assembly. Okay, so let's see. Bind shader. We have okay, so the problem so I think the problem is that I'm using one here when I shouldn't, but I'm going to validate that with our AI overlord. Yeah, so I need to it's hard working through this because I'm working on my Mac through this remote desktop tool, and it's like I have this input latency here, which is really annoying. So, yeah, it's fun. I guess we don't need to increment that anymore. And then where do I actually bind this thing? Okay, I don't see snow. I was hoping to just magically see snow appear, but that clearly wasn't happening. Yeah. All right, still mad. Missing vertex descriptor buffer binding at index 1. What? But I don't have an index 1. Where'd my music go to? I just realized the music hasn't been playing. Yeah. Yeah, that's kind of like the reason I like VS Code. I mean, VS Code is kind of has some latency too because it's built on like it's basically it's like a web browser, basically the way it's built, right? But it's more responsive than like any other IDE out there. And I got the compile code thing to work with my little plugin, which makes it basically like an IDE. And yeah. Okay, so what is the problem still? So we still have this issue. Okay, draw vertex descriptor buffer binding at index 1. So that doesn't make any sense. So it's mad about this still. So yeah. Yeah, you kind of have to like write a plugin or something to do it for you. Thankfully, I can kind of show this actually because it's somewhat relevant. Not that you'll probably actually want to spend the time doing this. But here's like the source code to my little plugin. And what's cool is through VS Code, let's see, where do I actually run these things? Yeah, VS Code gives you like this function. Where is it? What is happening? Yeah, you can send commands to the terminal through the send text thing function. It's kind of convoluted actually looking at this. I remember it being simpler, but it's not. But through the extension in VS Code, you can have it send commands to the terminal. So then if you just make your build system like a script, like here, my engine has a script for like actually bootstrapping the thing. And from my extension, I just call, like execute this script in the terminal and I pass in arguments that actually do stuff. And that's kind of how I bootstrap it from VS Code. And like here's like a shell script for Mac and Linux. And then I have it bound to like a hotkey so I can press, you know, F5 and actually just kick off a build. So like you could conceivably just have a script like this. This is kind of like a long script because it does a lot of stuff. But like at the bottom here, it's like actually calling you know, compiling a source file, which is like my little bootstrap executable for my little build pipeline. So like you could just have a script that just compiles your code. Yeah, okay, so back to... Is this just a fake error? I don't know. Sometimes these errors are like not real unless I recompile. Okay, so there's no snow, of course. No, this is real. Vertex descriptor. Buffer binding at index 1. I'm just confused because it shouldn't even be expecting 1 at input 1. Maybe I need to reset this to be null. Because I think this is being reused. No, it's not. It's being created here. I wish this was a little more informative about where specifically this was happening. API draw. For instance, draw snow. Yeah, so it is the snow shader it doesn't like. Okay, so where is the snow shader? So I'm pretty confident this works. Okay, so it is expecting, I guess, a binding at index 1. That's so odd. Does Metal just expect the instance layout to be in index 1? Oh, I see. Okay, I think the AI has just helped me out. This is like the most boring, the most boring content to watch. All right, so I was doing this buffer index. This also needs to be here. Because unfortunately, Mac wants this to be stated twice, pretty much. And I still don't see snow, which is concerning. But I think that will suppress this error, unless I'm wrong. No, really? What? That's crazy. Okay, I need to give it the full context of my function. It's interesting because I do this exact same thing pretty much in DirectX. So like wherever this function is. Where is it? Well, actually, where do I do that? Yeah, so I do like the same loop, essentially the same logic, just in like DirectX flavor. And yeah, I set that there. Let me read this carefully. So it's at this attributes offset thing. Let's put this. That should be fine. Let's build this. Hey, how's it going? 67, nice. 6-7. I still don't understand that meme at all, but that's okay. Okay, let's see. Let me think. What could possibly be going wrong? So that is fine. Attributes offset. That's funny, you're ahead of the curve. The whole 6-7 thing just like showed up out of nowhere, it feels like. And I don't know what's happening. Okay, so let's see, same error of course. Missing vertex buffer binding at index 1. It shouldn't be at index 1 though. That's the weird thing. Okay, so let's print some stuff. course, needs to be there. The OG. Alright, let's see. Instance. Bind instance. Wait a minute. What is happening here? This could very well be the problem. Look. Bind instance at slot 0. But here it's doing it at both of them. I'm not... It's not skipping this. Let's see. Vertex format. Oh, that is interesting. So the shader is expecting a vertex format here, but then I'm not actually supplying one. Yeah, it's going good. Fixing some stuff. The never-ending task of fixing random little issues. Okay, so I think I need to do the dummy vertex buffer. So like what's happening here is that the shader is still seeing a vertex buffer, but when I don't supply one, then it causes problems. Exactly. Man, this is a pain. Okay, so I think I was right before with this. So this should just always be 1. But if this is... greater than 0. Otherwise, metal expects this thing to be here. So 0. Yeah, exactly. Okay, this should fix that. Now down here in draw. It's always 0 and 1. Oops. Oh, there we go. Well, the snow isn't working exactly because it's not following my... I need to fix the mouse look on my Mac. It doesn't work. So the snow doesn't follow my camera. And again, it's probably impossible to see on the stream too because it's so small. But I think that's an easy fix. I just need to go into the shader. And where is it? Caps lock doesn't work. There we go. Yeah, this is my this is my little test project. I just have a bunch of random stuff in here. I'm excited to see that though. Trying to use CMake to open Collada. No, I haven't used CMake for that actually, but I have thoughts on that matter. Yeah, so actually, I don't know. So my engine, I have my own build system. So basically, instead of using CMake, I have my own little tool that runs. It's like a sub project in the engine. Yeah, what VM? Yeah, I'm using remote desktop. But anyway, yeah, like I was saying, so I have my own build tool, which it makes it easy because I can just write like a C++ program to like pack all of my assets and stuff. I'm not sure how you would do that with CMake because I know CMake is a little hard with dependencies and like the ordering of how it actually does things. So yeah. I don't have direct experience with CMake doing that, but are you talking about the project? Yeah, so like in this in this project, I just have like a really low quality model being loaded for the level. These are actually little levels I made for a game that I wrote like 15 years ago. And as a little nostalgic trip, I got it to work in my engine as like a model import. So these are all like really old files that I made a long time ago. But the actual like complexity of the models is just like as complex as you have a model file to load. Like I have a different project. Where is it? Here we go. So like here's like a separate demo project I have, which is like a globe. And this one has more complicated shaders because I like actually calculate the clouds like volumetrically. So they're simulated, so it has a more complicated shader. But yeah, I just use a low quality mesh for testing with my other little 3D project here. What's it mad about now? Oh, I'm still getting a seg fault. Interesting. Where did this one happen? What? Yeah. My mouse look actually works on Windows. But I have like, I don't know. This is a really basic little test level. I just use it for throwing a bunch of stuff together. Let me turn the fog off. Like I have like just a bunch of random things. Like here's like sorted transparency test I was doing. Now if you're making a real game, obviously you would spend more time actually doing like a PBR pipeline or something for physically based rendering and stuff. But I'm just working on the low level engine codes at the moment, so it's like I don't really care specifically what my shaders do. It's like, can I create a shader that is capable of, you know, being turned into a PBR pipeline, that sort of thing. So yeah, and this is a step towards that goal. I should actually test to see that this works. Hey, there we go. Transparency isn't working, so my blend modes are broken, it appears. And I was gonna say depth isn't working, but I think it might be. It's also super laggy. It's taking 50 milliseconds to draw that. What? It's all just deferred right now, or forward right now. I think if eventually I actually want to write a renderer, like that's kind of the end goal of this, once I finish this graphics stuff. And I want to do the clustered forward method, or forward plus it's called, where it's like you kind of bucket your lights into a, yeah, exactly. Yeah, so you know what I'm talking about. It's kind of like a tries to get the best of both worlds sort of thing. But it's kind of hard to set that up because I need a lot of just I need to support all of that in my my graphics layer. So like I need to get compute shaders in so you can generate like your data structure, your cluster grid thing. So that, yeah, and because like I've been stuck on OpenGL 4.1 and DirectX 11 because I was trying to support Mac. I didn't have access to compute shaders, or I don't have them yet, because Mac OpenGL doesn't support them. So it's like, well, now I need Metal because I want to do compute. All right, so let's see. What is next? Yeah. Yeah, that's the thing with the deferred pipeline is like you do deferred and you get like the benefit of having, you know, a million lights or whatever. You have low cost on that, but it makes working with like different material types. This music's really loud. It like makes it a pain to work with different like material types because you have to have some way of like, you know, determining what branch of the shader to run per material in your deferred pass. So you might do like a mega shader that branches on, you know, like the stencil ID or something. So like there's overhead there. And then like if you're doing a deferred renderer, you still need a forward renderer for transparency anyway. Yeah, it might be worth it to use a translation layer, to be honest. Once I get, I don't even have Vulkan implemented yet though, so that's not an option. And I'm gonna do Vulkan next, so I'm doing Metal, and then my next probably 2 months of live stream will be doing Vulkan. So look forward to that. But once I get Vulkan working, I will get the Molten VK working, just so I can run both Metal and Vulkan on Mac, and then I will be able to like definitively say which one is, you know, what the performance cost is. Yeah, I should do that. I'll drop my username in the chat because that could be fun. Well, my username is just my Twitch name, so you can probably find me. I don't have Twitch chat open right now to type in. So yeah, I'm kind of scared of Vulkan. just because, I don't know. I'm just scared. I think I'm in a good spot though, because I've had to do a lot of refactoring to get metal to work. But yeah, metal has kind of gotten me closer to, I think, the architecture that Vulkan and DirectX 12 will need. So like I'm making forward progress by kind of baby stepping my way out from OpenGL all the way up to Vulkan. It's quite the learning experience, actually. Okay, so I need to figure out why the blend mode. Yeah, here we go. I need to figure out why the blend mode's not working. I think I might have just turned them off. Okay, let's see. I keep getting lost. Backend, graphics, metal. Yeah. Yeah, I've seen those. I do have experience working with Vulkan, but I haven't implemented like my own renderer with it. Because I used to work at a AAA game studio, just for context. I worked at one for a few years as a rendering, like on the graphics team. But their renderer was already like basically fully implemented, so I only ever really worked with like their abstraction layer on top of it. But every now and then I'd have to debug issues, you know, in the back end, you could say. But it's like one thing to kind of poke into something knowing a high level how it works versus actually going in and doing it yourself from ground zero. Which is kind of the reason I'm doing this project too, is because it's like I just want to know how all of this stuff works. Okay, so apply blend mode. Yeah. I think deferred is kind of dying in general too. It's easy to set up a deferred renderer, and it's kind of like easy to reason about how it works. So I think a lot of indie games still use them. And there are a few AAA games that use them as well. But I think it's slowly dying, which is maybe a good thing. Okay, where apply? Here we go. Apply pipeline state raster. Where do I set the blend mode? State blend. Do I just not call this anywhere? Or no, it's this flag, I think. Does it actually? Wow. I'm surprised by that. It must be crazy working on an engine like Unreal, because you have you have like all this, yeah, you have like a deferred render, you have nanite, they probably have ray tracing as well, I assume. I guess that's what the Lumen stuff is, right? It's like a ray traced lighting renderer that partially works with nanite. I'm not even sure what the current state of the art there is with that. Blizzard. Is it what's his name? Is it Pirate Software? He doesn't look like he'd have worked there for 20 years. He looks kind of young. The depth testing isn't working either. I fixed the blend mode, I just wasn't testing. Yeah, I only worked for 3 years in AAA. It was interesting. I still work in like doing graphic stuff. I just don't work in games anymore. And I actually prefer it because I like doing game stuff. Like clearly it's a passion of mine. But it's a lot more fun to do game stuff just for fun rather than like doing it as a job. because working in AAA is kind of a stressful experience. I'll say that. And it's also a very slow experience. It's like code takes forever to get written and like submitted because there's just a lot of bureaucracy. It's like, I just want to code stuff. Okay, so I need to rethink all of this too. So what is metal blend operations? Attachment. You have a metal render pipeline color attachment descriptor. So I need to actually cache these things, I think, which I'm not doing currently. So what is this? Pipeline descriptor. Here, I'll be back in 1 second, actually. All right, I'm back. Had to grab a snack. Yeah, sorry. Yeah, so graphics, I was a rendering engineer. So basically the company I worked at is like, you had like rendering engineers, you had gameplay engineers, you had UI engineers. So most of my responsibilities were like programming, the engine, but like the rendering slice. So like writing shaders, doing the low level like rendering code. Also like asset streaming was related to rendering. So that's kind of the responsibility of the rendering engineers, was like the streaming of stuff from disk. So yeah, that's what I meant by graphics. Okay, I missed some chat. Yeah. And I understand what you said, 67 Alaska. Is like I said, I like to just program. But yeah, obviously in like a professional, company with a lot of moving parts, you can't just have people coding everywhere without, some checks and balances. So I fully understand why there is such, bureaucracy is the word I like to say. It's just, I don't know. That's why I like doing the side project for fun, because it's like I can just hack stuff together and then like, change it. It's just fun. Okay, so let's see. So the other big thing I need to actually do now, so like my metal renderer actually pretty much works now. Like this is rendering with metal, which is cool. Took a lot of work to get here. But the way I'm handling the actual state of like, I don't know, the state, I guess, is not, I'm not doing it very well because, well, I have a lot of to-dos here because I'm just kind of like hacking stuff together here just to get it to work. Like I don't even do stencil yet. I can have to-dos for my scissor, don't do that yet. So I need to actually like sketch out how this works. Metal. So in metal, you basically have a command buffer, and the command buffer takes, basically encodes work through encoders. I'm gonna capitalize these. You have encoders, you have like a bunch of encoders, right? And then you commit this thing. Right. And your encoder takes stuff like draw calls, compute dispatch, I assume ray tracing calls, and it also needs to take in state. You just have like a bunch of these. So in my, here, let me make sure I have the latest of this as well. Okay, so let me read the chat. Yeah, I agree with that. Okay, so encoder. And then, so we have, what do I all do with encoder in my backend? So we have viewport. I need to like make a list of all the sort of mutable state that's set on the encoder versus what's set on the command buffer and what's set like globally, just so I know how to kind of map my API to the actual calls here. So vertex texture, so we bind textures. I assume the scissor is on here as well, I would imagine. I don't know why I'm looking at this code actually. I should just... So we have... And what else? Depth stencil state. So this depth stencil state is actually its own separate object, which is interesting. Because you have this like MTL depth stencil state. So this is like some separate concept. And then you apply it. Let's see. So like I need to remove this. What's the depth descriptor? Yeah, you have this thing. So like I'll need to cache these as sort of separate things that change. So right now I'm just creating these and deleting them every time I set the depth state, which is kind of dumb. New depth stencil state with descriptor. And this is on the device. So let's see. And then what else is there like that? I think the stencil state is the same way. Depth stencil descriptor, depth stencil, so. I should really unify how I'm doing depth and stencil state because they're kind of the same thing. And then set scissor. Draw, of course. Yeah, so we have a render pipeline state. Yeah, so this pipeline state is another thing I'll need to cache. So what is this? Pipeline descriptor, where does this come from? Let's see. So what goes on to the pipeline descriptor? What else does this take? A label, that's fun. All right, let's see. So depth state takes I'm gonna ignore stencil stuff for now because I don't actually support that fully. So we need like some functions to make this easier to handle. This is where I basically break everything for a little bit. So we need a function like metal. Prepare pipeline descriptor. And then we have like metal prepare pipeline state. Yeah, so all of the encoder state you basically can't cache because it's like for every set of encodings you kind of just have to apply this stuff. Under pipeline state, so it'll be up here, pipeline state, depth stencil state. Hello, hello. Peru. It's awesome. Peru, Peru. I was watching a documentary or like a YouTube video recently about, it's like the highest town in the world is in Peru, I believe. People live at like this extreme elevation. They have, because there's like mines or something up at the top of the mountain. All these people have like these special like adaptations to the altitude. It's kind of crazy. It's like Tibet. Tibet's really high altitude as well in Asia. Okay, so let's see. Set depth stencil. So these are like pipeline descriptor. This comes from what? Apologies for this somewhat boring. I'm just kind of organizing my plan here. Yeah, that's actually really interesting. Yeah, I like to do running, like long distance running. And I know that like Olympic athletes and stuff that like run like marathons, they'll train at high altitude so they can increase the, I guess, yeah, the hemoglobin in your blood. So then when they race at sea level, it's like they can just absorb so much more oxygen because it's so plentiful compared to where they're used to living. And I always wonder if the people that live like with those adaptations would be insane endurance athletes at sea level. That'd be crazy. Okay, so I think this is everything I need. So we have the call mode up here. Yeah, these are just simple flags. Is there anything else I'm missing? Triangle fill, viewport, scissor, vertex texture, fragment texture. I guess you'd have like other textures in here. So the pipeline state is something I'll need to cache. So I don't know how specifically I want to do this yet, but we will just start writing code and see what happens. So I'm just gonna do these here for now. And I guess we will give the command. What's on the command? So I only really care about this guy, the pipeline. Call this pipeline state PS, because I am not immune to 2-letter variable names. So let's see, pipeline descriptor. We'll start with the encoder first because that's easiest to reason about. So we need to actually put these down a bit further. So I guess we can stub these in right away. Okay, so my first pass of this, I'm just going to get this to work without caching anything, and then once I have that working, in theory it should be trivial to just store this stuff in like a hash map with a lookup based on the pipeline state key. So we're not constantly like creating these things every single time we have a new permutation of state. Because that should only change if anything actually changes with the draw state. So let's see. So that creates that. And this should actually be up here. My bad. Need some static stuff as well. I guess we also have this render pass descriptor thing. So where do I create this? Like I don't need to be creating a new one of these every frame as well. It's kind of stupid. label. You're not wrong. You're not wrong. Okay, let's see. Prepare targets. Prepare shaders. Here, we'll prepare the shaders first, and then we'll give it some targets. Unfortunately, the depth state is part of the pipeline descriptor, which is annoying. So I need all of these little helper functions. I guess I really don't have to pass this thing along, do I? Because it's a global variable. I guess ideally I would, but for now I'm not going to. This goes in here. To do. I actually have cached. I'm doing this in a two-phase approach. First phase is the get it to work phase, Second phase is the optimize phase. It should be simple to cache once I actually have everything else done. But we'll see when we get there. I just need to work at this piece by piece here. So where do I have bind shader? Oh shoot, this takes a lot of stuff. So bind shader is called in like one spot. So I can just copy all of this. All right, so I don't actually have the resource here, so I need to retrieve that. Oh, is that actually... I do have the resource, don't I? That's actually really convenient that I have that. So I need to cache these things too. There's a lot of caching here. So I just don't want to be constantly like allocating these things. Every time I do an alloc init here, it's like this needs to be cached because this will never change beyond the first time you ever like enter this code path. Okay. Should just cache this whole step here, actually. last setting is the blend modes. Which is this, I believe. And I guess this should go probably at the bottom here, because that is related to this. Actually, I'll keep this separate for now. So in theory, I can start cutting a lot of this code out. If 0. What do these do? What's the drawable render descriptor? What is this? So that kind of goes in the encoder. Okay, I don't need the split screen anymore. What is all of this? I don't need this anymore. It's actually nice 'cause I'm simplifying a lot of this. So this was depth. This was... I haven't done depth yet. So bind shader. Do I have a state for that? I don't think so. State raster, blend, depth. So I need to do depth next. I guess these could just call these directly. Well, there's a sampler descriptor too. Set fragment sampler state. So we need that as well. Okay. this is kind of annoying because the sampler state isn't part of the pipeline state. It's like its own separate state thing that I'm forgetting about. Do I apply this globally anywhere? This is like my third game engine, I would say. It's kind of hard to say because I've made. This is my first general general purpose game engine, I guess you could say, and that it supports multiple different projects within it. But I've written like games that have their own engine before. Yeah, sorry, I'm kind of I was deep in the zone here, so I'm not talking. But yeah. This one's way more ambitious than my previous game engine projects. Okay, let me see. Where is this set? Yeah, right now I'm kind of doing, to explain what I'm doing at the moment, I'm doing a somewhat big refactor on my, on my metal graphics code. It's been like a project I've been chipping away at for like a month now, is getting metal API supported in the engine like natively. Yeah, it's been quite the project. I think it runs right now. I'm not sure. Yeah, it's tough to say, to be honest, because it's like I do spend a lot of time thinking about like the abstract API, where it's like maybe the time I've spent trying to abstract it, I could have just spent that time writing like each API specific implementation. I think like architecturally, it's nice to just have like a single, forward facing API for like game code. Because that way you're not thinking about like, there's just a bunch of edge cases that you have to worry about between the graphics APIs that like ideally you shouldn't have to remember when you're writing game code. So like if I can get the abstraction right, I can just handle all of those weird edge cases sort of automatically. And then in theory, it should make writing the game code really quick. But I don't know, this project's also just sort of like a fun sort of educational project. So I'm not making like a product or anything with this. So it's kind of just fun to work on this stuff too. So I don't know. But yeah, the engine, so yeah, currently I'm on Windows right now, obviously, so I can't test the Mac code. But I do have like the abstraction that it like works fairly well already for OpenGL and DirectX. So like this is running OpenGL. What's cool is you can just like quickly switch between that and DirectX. Which like on Windows, realistically, you wouldn't really need two APIs because you'd pretty much always just run DirectX because it's faster. But since I'm supporting Linux, Mac, and Windows, you kind of need to support multiple APIs. And like I've gone so far in that I've also abstracted the shader language itself, which is kind of yeah, it's static. So because like my general idea is that like you can just profile and you'll see that DirectX is fastest on Windows, and like Vulkan would be fastest on Linux compared to OpenGL, and like Metal is fastest on Mac. So like if I'm actually shipping like a distributable of the game, like in a release build, I would just like ship the DirectX binary in the Vulkan binary for Linux. But I need to support all the APIs like at an engine level, because as I'm developing, I will be jumping between them. Because I know it is popular. Like the other approach is you do like dynamic dispatch of the API, where you have like, you can create, you know, both a Vulkan context or like an OpenGL context at runtime. I think that kind of complicates your code though, having support for both. So I kind of like just compiling in the one that I'm actually using. But yeah, it's kind of a trade-off in that respect too. But yeah, like I was saying, I also, in my engine, I support what multi-APIs make. Yeah, because the cool thing is, like, I just directly compile in the actual like code that the backend is, like, the API is using, depending on the executable that I'm compiling. I'm doing a bad job of explaining that. But like the way I've kind of architected it is like I have these functions that I just call like API draw. So this is like my backend function for like dispatching a draw call. And like I'm in the DirectX 11 source file here. So obviously this will call DirectX 11 specific, you know, API calls. But in Metal, for instance, you have like the similar thing, except it's going to call you know, Metal draw indexed, you know, draw functions. And then depending on the backend that I'm actually compiling with, it will either compile in like the DirectX 11 source translation unit or the Metal one. So it all just links statically at, you know, compile time, I guess. Link time, I guess. Yeah, and that way I don't suffer any indirection cost as well. Which would be minimal. Like the indirection cost is pretty much nothing. But it's still simpler, I guess you could say. What was I just doing? Yeah, but right now I'm working through this Metal code. I'm doing a big refactor of my Metal. I can actually test the Metal here. I have a remote desktop going into my MacBook, so I can work on both from my my Windows PC. So the Metal renderer is working. So this is with Metal, but it's there's a lot of glue holding this together at the moment. So I need to formalize a lot of this, which is what I'm working through today. So wherever I just was. Need to be in. Yeah, and then after I do this, I need to do Vulkan. So my next couple months are booked up with graphics related work. Yeah, it is open source actually. If you in the description, there's the link for it. If you see it, the GitHub. Well, I guess it's open source in that I have the source code available for like anyone to just use or look at. I'm not actually like designing it as a official project or like an official thing, because like it is just like a fun hobby project for me. But I think it's at least valuable to make the source available, because there's no point gatekeeping it or anything. But yeah, Vulkan's gonna be a pain. I'm kind of like working my way up. Like I started with OpenGL and then I did DirectX 11, and now I'm doing Metal, which is kind of gets even lower level, right? And even Metal is like is a high level version of like DirectX 12 and Vulkan, but you have to do a bit more explicit, I guess, state management on your own with Metal. So yeah, it's kind of insightful. Eventually I'm going to deprecate OpenGL entirely, I think. Once I get Vulkan, DirectX 12, and Metal, I'm going to get rid of OpenGL. Just because it's like, I guess, not really worth supporting OpenGL going forward. Yeah. The main reason I'm doing it is because I have a MacBook as like my only laptop, and I do work on this when I'm away from home a lot. So I kind of had to get my engine working on the Apple ecosystem just because that's the laptop I have. But up until now I've been using OpenGL for Mac, but it's annoying because Mac doesn't support OpenGL beyond like version 4.1, I think. Which is like most of the modern features, except you don't have compute shaders because those didn't come until 4.3. So I up until now I haven't been able to do compute shaders in like, I guess, the cross-platform API layer that I'm working on because Mac doesn't support them in OpenGL. So it's like, well, I might as well do Metal, get that out of the way. I could have just done straight to Vulkan and used Molten VK to like get Vulkan working on Metal or on Mac, but I figured I'd rather at least support Metal natively if I'm going to do the work for it. Okay, so, and I'm almost done with the Metal support, so it hasn't been too bad, I guess. Okay, so I need these functions. Yeah, that's fine. That's why I'm streaming. It's fun to chat about it. I'm kind of surprised people actually watch this because, I don't know. Like, I feel like a lot of this stuff isn't that interesting unless you're actually, I don't know, unless you do this yourself, I guess, which is fun. But yeah, and like, like I started to mention before, I also have my own shader language that I wrote for this project, which is taking it probably a step too far for like an actual product. But I was getting really sick of writing multiple versions of shaders for each like shader language, for each API. 'Cause, you know, you need like GLSL and HLSL and Metal. So I was like, well, I should just write my own shader language that can cross-compile or get translated. So I worked on that for a while. And I do know that SPIR-V cross exists as a way of like cross-compiling. So I didn't do that like ignorantly, but yeah, I was working on that earlier today as well. I was trying to find the source code. Yeah, I agree. So like this globe project, kind of show it off quickly. So like this is my shader language. I just call it .shader. And it's basically like, I don't know, HLSL, I guess. But the cool thing is when I compile, you can see on the right side here, I actually have some stuff in my debug output, but it's like it compiles these shaders at build time. Maybe I should say translate, because it's not really compiling necessarily. But like it takes that shader, and turns it into HLSL. And then like I can switch to OpenGL and you can see that this will change if I stop running the game, of course. So now it's like wherever it is, output. Yeah, so here's like the GLSL. And I have the same for metal, which was actually kind of a fun project because you don't fully appreciate sort of the syntactical nature, like differences between the shader languages until you actually have to start thinking about how you do something like this. And the cool thing about doing this, the shader language, myself, is that in my shader language, I have it, like I have these, basically structs, I guess you could call them. But for like the vertex formats in the, I guess the fragment intermediate stages, I guess. Since I'm defining these in the shader anyway, right? In my compiler, for the shader like compiler, I can generate C++ code for the like the vertex bindings directly from my shader code. So I have like this fully automated system now where like from my shader code, it will generate all like the input layout bindings that my shaders need when I bind those to like the pipeline. In like uniform buffers, it generates C++ structs from my uniform buffers in like constant buffers that I can just immediately access in my C++ code, which is really convenient actually. So like here's like a generated, yeah, I basically generate the glue. And now this was the part that was a pain in the ass because so like here's the uniform buffer that gets generated. So it's like a C++ struct that I can access in the rest of my code. But one thing you don't appreciate, I guess, is that the padding and alignment rules of like structs is different between HLSL, GLSL, and metal. So like I had to write the logic to manually add like padding in these structs so that like the data actually aligns the same way it's accessed on the graphics card, which was not very fun, I'll be honest. I'm trying to find an example of where it pads weirdly, but I can't find one. This struct actually tightly pads, which is nice. Tightly packs. Yeah, exactly. But the cool thing is that once I figure that out, it's like I generate the glue here and I'll never have to think about it again, which is really nice because it makes like creating shaders just super fast. Like I can kind of demonstrate how convenient this is with this project. Once I close this, I just hit run like 50 times. Yeah, so here's like the globe project. What's cool is like I can just easily come in here and just define a uniform buffer and put it at like slot 1, or maybe I've used that. Call it like example. So like I could put like a color here or something and just multiply this by the color, pass it in. Type. Yeah, so this is how you like pass in uniforms in my shader. You have to pass them as parameters. Yeah, it's like, there we go, I just made a uniform buffer here. And then I can just go into like the C++ game code here, like the main function, I guess, anywhere you want. And I can just like set this thing here. So I can set to like red. I have to upload this thing. And like, it just immediately, it all just works. And then I have the little developer console in my engine too, so I can go like, hook it up to a development variable, debug variable. and then just pass it like this, and now it'll be black right now. But like now I have access to this through the dev console. Whoa, what's happening here? It's kind of crazy. I don't know why it's doing this. That's weird. It's like not clearing the frame buffer or something. Anyway, whoa, that's crazy. Oh, it's because of the transparency. Whoa. That's actually a cool effect. I've like added blur without even trying. That's kind of cool. It's because I set the transparency with that color multiply. But yeah, and the cool thing is that it works for vertex formats as well. This is like my pitch when people come on the stream and ask why I wrote my shader language. Is that this works the same for vertex formats too. So like, I don't know. This vertex atmosphere thing, this is for the atmosphere shader. So like you define this in the shader code and you can specify how it gets packed as well. But in the C++ code, I can like just easily create a vertex buffer and then like the type here, this like vertex atmosphere is just an accessible type now in my engine. So like, I don't know. It's not, doesn't like that for some reason, but probably GFX vertex buffer. There we go. But if we jump to this, we can see that like this is the struct that gets generated in this generated file. So it's just pretty neat, I guess. I don't know why I have this random print stuff here. Yeah, so make sure I didn't break the compile. I did. Yeah, I guess so. I don't know. I mostly just like, I'm trying to like optimize the development experience, I guess. It's like one of the goals of my engine. It's like, if I'm going to make my own engine, it has to be like enjoyable to use. So kind of having some of these quality of life features just like within the engine and the build system is like a nice thing to have. So because like, to be honest, I kind of hate graphics programming in that like, I hate the way it's so annoying to like, it's just, there's like so much glue necessary for like, you know, binding resources and, I don't know, just like dealing with shaders, dealing with, like synchronization of, you know, all the various things that you have to do when you create a rendering pipeline. So like my philosophy has been to just try and solve all these problems. And I don't know, maybe I'm succeeding, maybe I'm not, but it does come at the trade-off that there's more code to maintain, because now I have this like system in my engine that if anything ever changes, I'll need to possibly maintain it. Yeah, so that's that's my TED talk on that. Okay, so yeah, I'm still working on this metal stuff. It's kind of, and I did a big refactor of my graphics stuff a few weeks ago. Yeah, because I'm just like trying to hone in on the right architecture for this abstract graphics API I'm working on. It's pretty tough to like find a good, you know, abstraction. Because as I started working on metal, I realized I was like tracking state in kind of a bad way, or like a way that didn't translate well to the modern APIs. So, okay, what is the viewport or the scissor need? Yeah. Like my old API, I guess I could call it, my previous iteration, it was very similar to, I guess, OpenGL, where it's like a global state machine kind of, and you just like submit draw calls and you set the blend state and you set the raster, or you set like the call mode and all that. So you just kind of have like code everywhere that's like setting state. And then in like behind the scenes in my OpenGL backend and DirectX backend, I was kind of keeping track of my own little state machine and then translating that to actual like OpenGL and like DirectX API calls. I don't know why my screen just turned off. 1 second. Sometimes I had a cache, yeah, and I was I was diffing. I was like testing if the cache was like, if I set a state but it was the same as what's already set, you know, I wouldn't actually submit like an OpenGL call. Okay, let me fix this really quickly. Okay, it should be visible again. Whereas now I've transitioned it to be more better aligned with the concept of like the pipeline state object, right? And like the command buffer. Because ultimately that's kind of how the graphics card actually works, is you have like this pipeline state thing. And this should make it easier to cache the state as well. So that's kind of like, in the code I'm writing right now is I'm just like sort of formalizing that in my Metal backend code. Because in Metal, I'm not sure how familiar you are with Metal, but you have a command buffer, which is kind of like the thing that you encode, you work into. But then within the command buffer, you have encoders. So the encoder is kind of what is analogous to, I guess, the OpenGL global state, except it's like relative to an encoder. And it's just like, but it's like the encoder only encodes certain things. So like in an encoder, you have like, you know, the cull mode and the triangle fill mode and like the textures that are bound. Yeah, exactly. But like in Metal, they also let you set like the depth stencil state separately from the encoder. So it's like a separate object, and then you can, you know, apply a depth stencil state object onto the encoder. Whereas I know, I always forget if it's DirectX or Vulkan. One of them is more strict than the other. It might be Vulkan or DirectX. I don't know specifically. I haven't looked at it. But I know like in those APIs, this is all just like one sort of baked in thing. So if you change any of these, you have to like create a new pipeline state object entirely, or like retrieve one from cache if you've already created it. So I'm just trying to better align my my API with that sort of flow of state management. Okay, so scissor viewport. I need to do viewport. Oops, wrong one. But yeah, I think yeah. So yeah, I think this is a good stepping stone into Vulkan. I don't see any obvious problems with it yet. I guess there is like you can multi-thread, I guess, a lot of this stuff in Vulkan, and Metal too, I guess. So that's something I'm not currently accounting for, which might be a mistake. But I also don't know how much I'm actually going to be doing. Yeah. And I actually don't know, because I don't know yet. I don't even know what those are, so, so it's kind of scary thinking about Vulkan. But We'll cross that bridge when we get there. Actually, I'm gonna look that up because I'm curious. Push constants, Vulkan. Oh yeah, okay. So limited size through shader, very simple. These are like uniforms, I guess. You can render arbitrary meshes now. Send small amount of data to the shader. It can be very simple to perform away. Let's see. Ooh, mesh pipeline, yeah. Yeah, that makes sense. Yeah, so like what I use, I guess, my little uniform buffer for, you would probably use push constants for that. Yeah. I guess it's kind of tricky too with that because, like, if this is a Vulkan specific sort of concept, it's like, how would I design that into my abstraction layer so it also works with metal and I guess DirectX? I assume they might have. Whoa, my microphone's acting weird. 1 sec. Just like breaking on me. My microphone drivers are dying. Yeah, it's like, it's tough. It definitely gets tough. Because like ultimately too, it comes down to like, maybe you just don't support certain features if they're not supported across the board. But at the same time, like maybe that does lead to a somewhat significant performance increase. So you kind of want to expose that and use it where it's available. So like if I'm compiling Vulkan, use the, the optimized sort of Vulkan push constants. Yeah, that's interesting. I will certainly be thinking about that. All right, so let me see if scissor. So MTL viewport, that should be done. And then scissors last one. Do that. Texture bindings here. So we create a scissor rect. Basically just need this. Yeah, and the other thing I want to support at some point is I'd like to support web GPU as well. Now I'm just thinking about the differences between the APIs. Because I think it'd be really cool to have like a web target available in the engine. So you could do like, what's the VS Code that allows you to have shortcuts to the bottom? That's a custom plugin I wrote for my engine. You can write plugins that create little widgets. And I just have one that kind of helps me create little terminal commands to sort of bootstrap my engine. But yeah, I want to do web GPU, not anytime soon probably. But the downside with web GPU is that it doesn't support bindless resources, bindless textures. And once I get the full Vulkan Metal DirectX 12 suite implemented, I'm going to switch to bindless. Just because I think bindless makes a lot more sense. Just from I don't know. It's more efficient too, actually, because you can, you don't have to worry about doing like texture bindings at certain slots, and you can batch draw calls better with that. But anyway, yeah, WebGPU doesn't support bindless resources because not all of the platforms that WebGPU runs on support bindless. So that will be a problem because it's like, if I want WebGPU, I'll need to either support like non-bindless or, I don't know, emulate it somehow. Yeah, that's another one too. Yeah, like WebGPU is a simplification. Yeah, so if I'm gonna deprecate OpenGL from the engine once I'm done with Vulkan and Metal, because OpenGL doesn't really gain me anything at that point, I think. Because like with the 3 of those, you can sort of cover every case. But yeah, if I do WebGPU, then it's basically like having an OpenGL version again. So maybe I shouldn't do WebGPU. Okay, so I need const gfx state scissor. This should be state.width. This scissor stuff is completely busted too. I don't even know if I need to flip Y on Metal. It's like an OpenGL concept. It's interesting how the viewport in Metal has a near and a far plane as well. It's kind of odd. Prepare scissor. I can't wait to compile this and then fully watch it it crumble apart because I'm missing something. Okay, so we need command execute. What do I have this frame thing here for? Okay, I think that's everything. I'm gonna disable the scissor though, because I know that's actually not working. Oops. I have a lot of code to delete here in a little bit. Let's see. do need this. I'm not blinking. I'm locked in. That's the problem. I'm locked in. Yeah, this is a lot of worry. I'm just like making sure I'm not forgetting anything. Bind shader. I don't know if I called this. Bind shader. Let's see. I can delete this. I don't need this. Yeah, okay, so I call that trying to figure out what this was for. Uniform buffer, so I guess I need that. There. And hey, how's it going? Welcome to the stream. I am deep in the weeds here. Deep in the weeds. I'm afraid to compile this because I know it's gonna be a game of whack-a-mole to get this to work. What is this actually doing though? State-bound uniform. Oh, this is set per draw call. Okay, that makes sense. Yeah, so we prepare the encoder, we set the uniforms, and then we draw. I think I have everything accounted for. I'm doing the game of I don't compile for 2 hours. Yeah. I do OOP a little bit in some areas. But yeah, I tend to go more data oriented in a lot of things. Like I do have an object system, an entity system, I guess, that's very, very OOP in nature. So I didn't do an entity component system. I might change that eventually. It's kind of a low priority at the moment. But most other things are data oriented. Okay, I'm just gonna compile this, see what happens. I know for sure I've missed something, but we'll find out in a second. Oops. No, I don't want Discord open. The translation of which part? That can mean a lot of things. There we go. Okay. So, state. Yeah, it doesn't know what state is, of course. Which function was that? Which line? 650. So pipeline descriptor. It's mad about this. Type argument metal pipeline descriptor must be a pointer. Really? I don't know what that means. This is like objective C++ jargon. I don't know what that means. If you're talking about like shaders, I have a shader compiler that I use to translate. So I just build the engine, I guess, natively for each platform. And then I pick, you know, the implementation depending on the platform that's running. So like the graphics layer will use whatever API is available on the platform I'm running on. So that's why I'm working on Metal right now for Mac. The window system, so like creating the window, when I'm compiling for Mac, I just use like the MacOS windowing API, I guess, which is Cocoa, it's called. And like if I'm on Mac and I'm creating a thread, I use like POSIX threads. So like everything's sort of implemented depending on the platform, and it's like conditionally compiled in based on the target. So I only compile what's being used for any given platform. So static. Oh, this needs to be like this. Interesting. It will be, yeah. You know, it's gonna hurt, but you can't be too married to the code you write. So, I think for the future, it's good to cut it off. I mean, if it's still in the Git history, right? So if I ever want it back, I can just bring it back. Yeah. And I can explain why I kind of did that too, because this is a little intense, doing all this. But I've tried to keep compile times fast in the engine, so I'm like trying to use as few like outside dependencies as I can. Just because like when I write these myself, I can just keep these things like as trimmed down as necessary to like use exactly what my engine needs. And that actually makes a big impact on compile times. So I think the trade-off is worth it just for like my sanity. So I'm not sitting here waiting like a long time every time I hit run. A lot of this is just copy and paste though, like this procedures and stuff. It's kind of like you add to this as you need it. Okay, so what's next? Yeah, exactly. And you know, okay, I my stance on AI is that I don't really like using AI for generating code, but it's really useful for getting like just weird edge case, like information about like just weird edge case or like, I don't know, API quirks and stuff. Because you can just like ask it and it will give you a starting point. So like doing this is actually kind of fun because you can just like kind of just learn about it. And if I get stuck, it's like, I'm never stuck for too long because I can usually find the answer. Sample count is deprecated, so that's fake error. What's next? State. Doesn't know what state is. 749. 749. Okay, yeah, pipeline state. Oops. I don't like working through this remote desktop tool because there's a lot of latency. Like I type and then it takes like a quarter of a second for it actually to do anything. Okay, what else is it mad about? This needs to be some other case. I'll be amazed if this works on like the first try, because there's just no way. Simply no way that this will work. Yeah, I guess the nice thing about being on Metal now is I have IntelliSense again. It's called Rust Desk. Rust Desk. And yeah, I'm not sure if Parsec does. I assume it does, yeah. I actually used to use Parsec at my old job. We used to use that. I should try that out. Okay, so what is it mad about? Yeah, I did mean that. That's correct. What is happening? And then what's this? Instance not found. What is this a part of? I do that here though. Wanting the at index. Objective-C is a really weird language. Alright, I don't see any other errors. Hey! The fact I see anything at all is actually a miracle. Wow. And depth testing is working now too? That wasn't working before? Wow. It actually works. That's crazy. Okay, here's the ultimate test. Does the globe project work? This is the one that's least likely to work. Hey, there we go. I'm actually so happy to see that. That's so exciting. Okay, now I can go and delete a bunch of code, which is always the best part. And then I have to think about caching things. I'm excited to see that because prior to this refactor, I couldn't even see the globe itself. Like, there's some weird thing going on with the depth state that was causing the globe to not render. I couldn't see the stars. So I've actually fixed it by doing this refactor, which is exciting. Okay, now to go and delete a bunch of stuff. So everything I have a to-do remove, I just have to cut this out. Like that. No, I just have a giant list of cities that it uses. Okay, what's this? To do set scissor state. So I need to fix the scissor state. And this as well needs to change. Yeah, I have like a giant list it reads from. So I'm kind of faking it a little bit. Okay, what else? Look at that. I've just simplified that function down into this. That's so satisfying. That's great. Unfortunately, I'm not done. I have a lot left to do, but that's a good starting point. So delete this. Yeah, it truly is. Yeah, it's coming though. It's coming. There's a lot of to-dos actually, aren't there? Like I'm compiling shaders at runtime still. I shouldn't be doing that. This needs to be completely fixed. Man, this is a pain. Okay, so I can actually work on these now. So these would immediately set the state. Let's see. Raster. Where do I set this? Let's clean this up. So there's two conditions. So this can either kind of defer the state change to the next sort of group of work, or I could be actively within like a command, like a render command. So it could imply, it would apply immediately. So I guess if encoder is nil, not equal to nil, then we would call I guess this should be because that sets it immediately. I'm really excited to do compute shaders though, because that opens up so many possibilities for doing cool graphics stuff. So that's the icing on the cake when we get to that point. Yeah, see, blend mode's the tough one because this is part of the let's see, the pipeline state thing. This is going to be tough to think about. Yeah. Okay, so let's see. I might come back to this in the future. I might leave that as a to-do. Okay, let's see. I need to fix this viewport code as well. This has been broken for a while. Okay, now let's see. See if I broke anything. I think I might have, but we'll find out. All right, looking good. Ooh, doesn't like this. Wait, what do you mean it doesn't like this? What? Ooh. I need to fix mouse look. I can't do mouse look on Mac. Okay, let's fix the viewport stuff next. So let me take a step back and figure out where I actually do this viewport stuff. So we have viewport init, viewport set size. So this is what we care about. Set the width and the height. I have some weird the problem with the viewport is there's like the weird dependency on the window creation too, or the window sizing. So I do some stuff here. It's like viewport, swap chain viewport update, which is here. So what does this do? I mean, in theory that should work, but something was odd about it. Yeah, it doesn't do anything. It just doesn't do anything. I mean, it stretches. But you can tell it's not working because it's like stretched weirdly. So I guess the question is why. Does OpenGL work for the viewport? Yeah, OpenGL works. Okay, for some reason this is calling every frame as well. Why is that happening? Oh, I guess this explains that. Whoa. So it is getting the new size. Or it's getting the update. I guess what I should do probably is set the viewport to be the swap chain size at frame start. I think that's what's happening. It's like preserving its old state rather than resetting. So like frame begin, we would go like, no, that's not working. Interesting. Oh, I see. I was just hard coding this. That explains it. Oof. What is happening? I'll be right back. I'm going to step away for a second. Yeah, sound API glitches are the worst. I have a nasty one in my sound engine as well. I think it's like a threading problem because every now and then I'll get like an issue where the sound doesn't actually stop playing, like it exceeds the I guess the buffer size or something. And since the mixer runs on a background thread, I think I have some weird like race condition, and I've really been procrastinating trying to fix it because it doesn't happen very often. But when it does, it's like it just destroys your ears. All right, let's see. Right. Yeah, because it's like if you have it wrong in any small way, it's like you're sending just garbage to the, I guess, the audio driver, and it just, yeah, it's a bad time. It's a bad time. Okay, so something here isn't working. It's interesting how it's like grabbing 128 by 720 from somewhere. I'm not sure where it's grabbing that. Where do I set the viewport? So I do this in a few places. So width and height here. So let's see. So when I jump into a render target, I set the height, the viewport size, which is what this 256 by 256 is. And then we set it for the let me think. Maybe that is right. I don't know. Let me get the simpler project out. I need to figure out what's wrong with this project. This one's not too happy. Static assertion requirement size padding struct gfx struct padded that test equal to size mismatch. Where? Okay, so I don't really care about this case right now. What does it think this is? Just going to delete all of this. I'm curious where it's getting this 256 by 1440 from. Do I have that hard-coded somewhere? It's like my monitor resolution. I don't know where to be grabbing that, though. It's so weird. I think I just need to print out what these values are to the screen just so I can like see what they actually are. Okay, so that looks correct. If I change this. Okay, so neither the swap chain or the viewport actually resize correctly. That's basically what I'm learning here. Yeah, iOS is a great font. Interesting. So somehow this swap chain size is never making it to the app. Because it never changes, even if I resize the window. Right, that just doesn't change. So I wonder why. Because that works in OpenGL, I believe. Right? Oh, I must have broke clear color in OpenGL. So what's happening? Oh no. What is happening? But the swap chain does resize. So my metal code actually works better than DirectX or than OpenGL, which is funny. Okay, let's see. So let's see which one. Swap chain viewport update. What does this do? Oh, it's grabbing it from the window. So I guess these need to change too, don't they? Yeah, here we go. Because this metal drawable resize thing is like a special case for the metal API. It listens for this, the window does. Or it has this function that it calls. It's like a callback that OpenGL doesn't use because it doesn't use a different interface. Okay, now it's kind of right, but just like grossly off scale. So it should be 1280 by 700. Oh wait, that doesn't make any sense. What is my cat doing? This is like the really annoying problem of the DPI scaling. And Mac applies like a scale factor by default on basically everything. So it's hard to like figure out which is the correct value. So I think this should just be what is happening? My cat's like doing something. Yeah, there we go. 1280 by 700. This looks right. All right. And then if you resize, it just completely dies. What's happening? Stop. Okay. Oh no. I've crashed the game. I've crashed. I've seg faulted. It doesn't like full screen anymore. Alright. Noted. Really? I don't know why full screen broke. It was working before. Oh no. Alright, 1 second. I need to get my cat. out of the cabinet. What is he doing? What are you doing? Get out. Why are you up here? Out. All right. If I can just fix this problem, then all will be good. It's interesting because it starts out correct. And then the resize is what breaks it. So I think this must be in my back end. Whoa. Okay, I need to simplify the problem here slightly. Let's see. So what is the value of this? What is happening? So I set the drawable size to new size, and that takes, what is scale factor? So the swap chain size is like the true pixel size on the screen, I believe. And then the scale factor is how many it's like how to downscale it, so you divide by the scale factor. That seems wrong, doesn't it? I guess that's like the true size. I wish DPI scaling didn't exist. This is just so confusing. You have like logical size and then you have like actual true pixel size, and it's just like, why are there two different numbers to represent the same thing? It's just so confusing. Okay, let me reason about this. So when we create the app, this is correct. Width, height. So window width and height are always in logical coordinates, right? Window size, where do I set the scale? Yeah, and then we get the backing factor. Yeah, I I have seen them through this. It's just like, this is so annoying. So my viewport is always a multiple of the backing scale factor. In my swap chain, those both need to be intervals of that. So let's see. Because I'm like doing the math incorrectly somewhere. Like I'm not multiplying where I should be. Or I'm like multiplying maybe more than I should be. Is this like a standardized concept, a logical? I asked ChatGPT because I didn't even understand what's happening here. So you have a logical size and a backing size. Is that like a standard concept across all of the... Because, let's see... Where is this coming from? This should just be window. Oh, wait. Yeah, that's basically what I did. I'm not accounting for something here. I know this. I'm just... Yeah, the chat GPT overlord will solve the problem. Like, is this even correct? Yeah, there probably are. Okay, so this is correct because these are this nsrect is always in, well, according to ChatGPT, these are always in logical coordinates, so point size. And my window width and height are in point sizes because that's like an operating system concept, I guess. And then so I need to update this. We're gonna have ChatGPT help me fix this. Goodbye, kitty. Goodbye, kitty. All right. So let's see. It says that I need to change something here. What did it change? New size. Okay, so I'm just gonna. Working through this remote desktop tool is brutal. Okay, so I don't even use this drawable size, do I? Yeah. That's why you don't blindly trust whatever it says. You have to like review its code. So far it hasn't really changed anything. It's just like cleaning up what I had written. Okay, and then we create the new metal layer with the pixel size. What is view size? Clean code. Right. All right. So I think I'm going to actually, just so I'm never confused about this again in the future, I'm going to store within pixels as well. I'll have to clean this up eventually because I just don't like how I have like two different coordinate systems here. It's like you have a logical coordinate system and then you have like your actual true pixel size coordinate system. And I think like 99% of the time I don't care about the logical size. I care about the pixel size because that's like what my renderer uses. So I'm going to clean that up at some point. So then, are all of these correct? Okay, so now when I call this function, I know I need to convert these. So when I get the this, okay, so I'm going to say width pixels, height pixels, because that takes the width and the height multiplied by our scale constant, which means we would have that and that. And I'm going to delete the concept of the viewport in the swap chain knowing about DPI scaling, because that's like a responsibility it shouldn't have to think about, because it just always works in pixels. So anywhere, actually I'm going to do most of this refactor on my Windows PC. Anywhere I call this, I just need to delete DPI scaling from all of this stuff. Oops. Layer.content scale. Why does it need to know this? Like Mac is the only one where the swap chain cares about its content scale. It's like, what is this? Okay, I guess swap chain does need to know its scale. But I'm going to delete it anyway because I don't like that. I just feel like it's the responsibility of the window. It's like it should be the responsibility of the window to like deal with the scaling of the viewport and like the swap chain, you know? Like that shouldn't be my application's responsibility. Or my renderer's responsibility. Yeah, exactly. And it's annoying because Mac is very aggressive about... Oh shoot, I need this. Mac is very aggressive about enforcing DPI scaling. So like layer.content scale, this is just the window scale. That's my dependency here. So I can delete that. DPI where? All right, well, I didn't break Windows, which is a good sign. I did break Mac, though. Or OpenGL. So now if I turn on scaling, $150. Well, maybe if I didn't have my screen so large. All right, that looks correct to me. I agree with that. All right, cool. I at least have it working on Windows again, so let's turn scaling back off. Close that. Let's finish this Mac stuff, because what I need to do in Apple, so now is anywhere where I do the window width, which actually is only there. Yeah, so this is what we'll need to change. So state. Isn't that what Vulkan is supposed to be? I thought that was the OpenGL replacement. What is my cat doing? All right, let's see. So state.width, what is this? Where does this get set? So I guess here, yeah, so we set these in pixels and we're making a replacement for Vulkan. Oh no. That's actually scary. All right, so. Hey, there we go. There we go. Things are starting to work again. It's exactly what I want to see. It's actually scaling correctly now. I still segfault when I go to the full screen though. Alright, so let's see the globe demo. Oh no. Oh no. That's unfortunate. Alright, so still some problems, but we're getting closer. So the question is, does this game still work? Or I guess it never did work to begin with. I don't know what happened to the background. Interesting. Nice. Okay, this matrix is not applying. It appears. Which is super bizarre. Oh, I see. Maybe? Yes, I will. Because I've been emulating it in a fragment shader is the what I've been doing, so. Let's see, work capture. For some reason the parallax background isn't working anymore. There we go. Yeah. Yeah, because right now I do it in a fragment shader. It's actually not technically a particle simulation. It uses like it's like a cellular automata. So it uses like it's like simulated on a grid. It's actually a pretty complicated little shader. But yeah, since I haven't had compute, I basically have to do it in a pixel shader with like frame buffers, render targets. So if I like view these, oh no, I broke it. I can like create some water. But yeah, in render doc, you can see on the left here, I'm doing a lot of simulation steps per frame, and I'm just doing them as draw calls, which is kind of dumb. Because there's a lot of overhead in that. So yeah, that'll be a big improvement in performance. And even still, it's still pretty fast. Like, it's an efficient simulation. But it could be a lot faster. Yeah. Because yeah, the world is broken into chunks. So I have the simulation that works on like a chunk basis. Because as you fly around, the world's kind of like loading and unloading around you. So the water has to simulate basically across that. I need to make better shaders for this. Yeah, it's a really efficient simulation actually. And the cool thing about doing it, I guess, as a grid rather than particles, is that the cost is like fixed. Like it doesn't cost more performance to have more water volume, I guess, because like it's already sort of built in based on the size of my simulation render target, I suppose. I don't know if that makes any sense, but If I uncap the frame rate, I get really high frame rate in this. Like I'm getting like 2,000 frames a second right now. I have a pretty good GPU though, so that helps. Now the test is see if I can get this to work on on metal. I haven't tested this yet. I need to fix this. So if we go back, one of these shaders wasn't compiling. So let's see which one it is. OpenGL. I'll be shocked if this works, to be honest. Once I fix the shader that's not compiling, that is. Okay, so let's see. No viable conversion from short to oh, did I just mess this up? Yeah, this should be U short. All right. It's clearly, oh, wait. Ah, no. All right. It almost worked. I wonder what it's getting tripped up on. Let's see. Nice. Okay, so render pass. Oh, it's the uniforms. Doesn't like the uniforms. That's interesting. So I'm trying to simulate too much at a time, it appears. So if I just turn off the simulation for now, what happens? Oh, that's right, I can't full screen. Yeah. Something like that. Okay, here's what I'm going to do. I'm going to I'm gonna do a bit of a hacky stuff here, but I think this should work. Let's see. So it's rendering black because the simulation isn't running. And the reason that's not running is because I'm not... I need to fix how I'm doing... I'm doing frequent updates of the uniform buffer. And I'm exhausting my buffer pool, basically. Like, in between a frame, I'm exhausting the buffer pool. So this is just like a big thing I need to fix. So where do I do a uniform? This will just be temporary. So like create this as a ring buffer. And I guess the size will be, let's do like, let's go 128. Just for fun. And then when we actually bind this thing later on in the draw call, yeah, yeah. I spent I spent some time the other week getting that to work. Yeah, so I have I can either do like write and then immediately overwrite, and then I also have a ring buffer which will just like reuse the buffer and then flip it when it's like at capacity. Okay, so let me see, where am I? Because now you do this offset thing, so I don't know if this will work immediately. Hopefully it does. No, not quite. Not quite. Let's test it on a simpler project first. Okay, so I'm missing something, of course. Is there like a size? Do I need to put a size on this? I thought that would work. Should it be that easy? Let's see. I'm actually surprised that doesn't work. 1 second. Let me just reason about this. Yeah, okay, I see what's happening. So I think what's happening is these need to be aligned by 256 bytes, essentially. Offset not a multiple of 256. Yeah, and this likely isn't, so like I need to align this, align. Which of these do I have? I can force this to be yeah, because I think what's happening is like my uniform buffer is some weird size. So for now, I'm just going to like artificially make this thing bigger. So like, because I know how I use this in my code base, but this will just get me to a point where it should work again. Let me get ChatGPT. Okay, this is going to be kind of a gross way of doing this, but this is just a proof of concept. Actually, that's what it had. Interesting, that's not what the problem was. Okay, so maybe it's not the issue. Xcode. Xcode to the rescue. Project. Whoa. Check that out. Okay, so it's not silently failing. This is my uniform buffer. I mean, actually, that looks correct. It's just entering null. Yeah, model, view, perspective, MVP. Interesting. Okay, so that's correct. Super odd. It's weird because it, in the capture here, the data it has is actually like correct, which is what's weird. Oh, that's not what I wanted. It's like my viewport's tiny or something. I don't know. It's weird. Because look, like you do see pixels every now and then. I don't know what's going on. It's weird. Co-founder. What's the idea? Struct size also rounds up to 256. I don't know if I want to work if I don't know the idea. Okay, I think I know what's happening. So if I change, sorry, I'm eating. If I change the, I think I finally reasoned through my mind what the issue is. So if I'm changing the uniform buffer many times before I actually call like draw with it, it's basically keeping the most, the first write, not the most recent one. Which isn't ideal. So I could, a few ways I could deal with this. I'm not sure what the best way is. Because I didn't think I would use it like this. Let's see. So we need like an offset and like an offset last or something. So where do I keep offset? So I think I need to do this. Let's see. This is a tough little problem to solve. So, init. Bom, bom, bom. So I think this should be false. There we go. Here I am trying to solve a problem I already solved. Now we see if this works. Not quite. We're closer to a solution though. I guess the real test is what happens if I look at this in a debugger. Oh, I think I still have the simulation turned off. Too many draw calls. I do not know what's happening. does not like the simulation. What is happening? Well, clearly I need to fix some stuff. All right, but for the sake of continuing to make progress, Well, hopefully someone in chat likes the idea. Alright, so let's see. What other to-dos do I have in here as well? Quite a few. I think I might have a memory leak too, actually, if I look at this in activity monitor. I was using 2.3 gigs. That's crazy. Yeah, look, I have a memory leak. Look at the memory just inching up. So we'll need to figure that out. Well, I have a pretty good idea what it is, actually. Yeah, so I should test the scissor now as well. Hard to see where the scissor is actually failing. Let me create a little test scenario. Okay, so that does work. It's just not applying immediately. And it's not resetting at the end of the the render command. Yeah, there we go. It's actually not working. Interesting. I think it's doubling when it shouldn't be. Yeah, there we go. Nice. You can just resize the window to be infinitely small. That's funny. Okay, I gotta get rid of a lot of this debug text. No, I haven't. Not at all. Thanks. Appreciate that. I think eventually I might consider operating systems. I feel like it's easier to make a game engine than than make an operating system, though. Honestly, the frame rate isn't even that good with Metal. That's weird. I get better frame rate with OpenGL. So I must be doing something stupid with Metal. You gotta start somewhere. It's a journey. I'm on, yeah, okay. So I'm working on Mac stuff right now because I'm doing Metal graphics programming, but I'm on a Windows PC, and I have a MacBook off to the side, and I'm just remote desktoping into it just so I can work on both at the same time. Because I can't run Metal code on Windows, obviously, because it's a macOS thing. So yeah, that's what's happening. I'm not impressed by the performance here in Metal. My Metal code is running slower. I'm curious why. Well, this is a good frame rate. It's like when I get close to stuff. And I don't have mouse look working on my Mac right now, so it's like impossible to control the view. Like, why am I getting such sporadic FPS? I started when I was 9 or 10, I think. I didn't really get serious about programming, though, until I was, like, probably 14 or 15. And I'm 27 now, for reference. Wow, even mip mapping looks horrible. Look at this. Why does it look so bad? Why is it so, like, choppy? For graphics programming, specifically, I can maybe answer that. No, you guys aren't cooked. A lot of time. Yeah, and the thing is, with AI tools now, it's so much easier to learn stuff if you're smart about how you use it. Because, like, I don't know, back before AI, you just had to, I don't know, find information just by luck, pretty much. But now it's so much easier to do, just to learn stuff, because you can, I don't know, ask like ChatGPT for resources and stuff. So I don't know. Yeah, I think learnopengl.com, I think it is. Let me see what the URL is. This is like the classic that everyone recommends. So there's this website, learnopengl.com. So this is OpenGL. Man, this is killing my eyes. But this uses OpenGL. But the, where's the actual like tutorials here? You can basically work through this step by step, and you pretty much get like a full walkthrough of graphics programming. And yeah, I think OpenGL is the easiest. OpenGL is a bit dated in how it actually like organizes like graphics concepts. So there is like a rather big difference between OpenGL and something like Vulkan. But when you're learning, I don't think it's as important to really care about those details, because it's like the differences are like implementation details rather than conceptual. And like when you're just starting out, the stuff you should care about isn't really the implementation details of Vulkan. you kind of learn that as you like progress. So like, yeah, so learn OpenGL is good. Textbooks, there's a textbook, another classic one. Textbook, let's see, this one. This is the textbook I have somewhere around here. I don't know if I have it accessible, but this is a good textbook. Yeah, no problem. All good. Yeah, and then just like by just doing projects is kind of how, at least that's how I learn the most. Like I personally don't use tutorials that much. But obviously if you have nowhere to start, you have to start somewhere. So tutorials are nice for that. I wonder why my frame rate is so bad. It's a good question. The real question is, what's my uncapped frame rate? Metal. Or cocoa. I'm actually not sure, to be honest. I don't really use Xcode for programming. Like I just kind of, I was like got into programming way before I had a MacBook. So I don't really, I'm not too familiar with the MacBook coding ecosystem. So I just use VS Code because it kind of works on everything. Yeah, like you could use Xcode. Basically, it doesn't really matter what you use as long as you have an environment where you can actually like compile the code and run it. Because again, like a lot of that stuff is like implementation details, which aren't super important. What's important, of course, is just having a way to compile code. Okay, so my frame rate is bad. This should be a lot faster. 123. It's just all over the place. What is it in OpenGL? Yeah, exactly. Yeah, and graphics programming is kind of cool because there's like a lot of different ways you can like go at it. Yeah, I got my degree. I have a computer science degree, but I was like self-taught before I went to college. So I kind of just went to college. I mean, I learned a lot of stuff in college, of course, but I didn't like, that's not where I started, I guess. And like the graphics stuff, I know it's pretty much all self-taught. Yeah, because at my university, there was like pretty much no courses in graphics or anything. There was one. It was like an introduction to graphics. But yeah, like I was saying before I got distracted. Yeah, the cool thing with graphics is there's like, I don't know, a lot of different ways you can actually like go about doing graphics. So like what I'm most interested in is like the game engine side of things. So like kind of writing the tools, I guess you would say, for like doing graphics. Whereas like other people are more interested in actually like writing shaders and stuff for like effects. and like implementing research papers and stuff. So like state of the art sort of visual effects type graphics, and less so on implementation details. Yeah, it's a lot of fun. Yeah, and then yeah, I've been out of college for about 5 years now. It's actually kind of crazy to think that. But my first job out of college was actually at a AAA game studio. So I was working on, I guess, game engines professionally for a few years. I don't work there anymore because I switched jobs last year. But I got pretty lucky getting into a position at like an actual company as well. So I learned a lot of stuff just on the job as well. Or at least what I'm doing now for fun is inspired by stuff I did when I was working there. All right. Oops. So one's 50. Okay, this one's about the same. 170. Yeah, no problem. That's why it's fun streaming. I'm kind of reaching the end of my my productive work cycle here. I've been going at this for like 6 hours now, so my brain's a little fried. I made some good progress today, though. Vibe coding. Yeah. I think the problem is I just like programming stuff. It would be awesome to be self-employed or like create a company or something. I'm terrible with ideas, like business ideas. I just have little interest in that personally. So I have a full-time job right now that I work. You know, pays the bills. And I just program even more for fun on the side. I'm curious what my bottleneck is. Ooh, what happened? Why don't I want to build $1 billion? I mean, I do. I just don't. I'm not like a businessman. That's the problem. It's like, what do I build? You know, it's the toughest part. It's like the what. What do you do? I mean, I have this game engine project, but it's like there's a million game engines out there. Is anyone going to use mine in particular? Yeah, I can tell. And that's good. Yeah, I like it. I like the ambition. I could be a YouTuber. Have a great product. I mean, like, ultimately you need to solve a problem, right? So, like, if you're going to have a great product, it's like, it has to be better. Yeah, thanks. Thanks for stopping by. Appreciate it. But yeah, you need, like, a product or an idea that's, like, a net positive that people will actually want to pay for, right? So like you either need to be better than what's already out there, or you need to create a new space that people don't know that they want yet. And then the idea needs to scale too, because if you want to be a billionaire, it's like it's like your idea has to be worth $1 billion, right? At least. So, you know, what global industries have $1 billion in potential growth or market cap? Which there's a lot of those, I guess. So I don't know. Like game engines, obviously. Well, maybe game engines don't specifically, but games do. But there's a lot of games, so it's like maybe you shouldn't get in the games market. I don't know. It's interesting. I probably am. There's also risk involved, though, too. Because it's like, I don't know. I have bills and stuff to pay now. So, like, I can't just, you know, screw off for 6 months and go try to become a billionaire. Maybe I could. It's all about risk tolerance, I guess. I love it. What is happening? Really? FPS overflow. It's kind of true, though. I don't even disagree with you. And like I guess the thing you have to think about is that like there's no reason you can't be successful, right? It's like entirely a mindset thing. I mean, of course there's luck involved too. It'd be kind of pretentious to say that there's not some factor beyond just like hard work, but it's like for most people, if you really put the effort in, you can be successful, assuming you're in like a country or place that kind of allows that to be true. Which I am, of course. So yeah, if like you just accept that you're not going to be successful, and obviously you won't be successful. Yeah. And like a lot of times what looks like luck is just, you know, the result of like opportunities, right? Like you have to put yourself in positions where luck can, you know, fall upon you. So if you're not doing that, then you're not going to be lucky as well. It's like you can increase the odds of your luck happening at least. Okay, I am happy with these changes. Yeah. Yeah, I agree. Now I'm getting inspired. The inspiration's hitting. I just need to think of an idea, though. I need to be an idea man. Maybe I should just start making, you know? It's like, maybe you don't need the best idea. You just need to, like, actually do stuff, and then one of them will take off. I don't know. All right. I don't know. What else do I have to work on tonight? I've kind of, like, done everything I wanted to do. guess I can I'm a monster. I could do apps. I don't know. It's just like, yeah, I don't know. There's a lot of opportunity to do things. What's happening? I'm getting messages. All right, so one thing I need to fix is projects. All right, I need to fix these compile issues. That's a good point too. I think maybe what would what would work for me is if I feel like I'm personally not the person that's going to be out there like I don't know, hustling super hard to be a billionaire. Like I'm not an Elon Musk or something. But I feel like I could do good if I would, if I was like working for someone that was like that, you know? But when you do that, then it's like you're kind of on the sidelines. So at that point, I don't know. It's like, do I want to be on the sidelines? Who knows? Okay, is this compiling yet? No, it is not. Read-write barrier. What is going on? Undefined reference to read-write barrier. What? Why is this erroring? Did you mean to call fabs? What line is that? 114. What's a YC? I don't even know what that is. What is a YC? Y Combinator? Y Combinator? Yeah, okay, I've heard this. I still don't even know what this is. I just hear this all the time. It's like a CS career questions Reddit type post. All right, let's see. I should sync this. Sync. All right. I'm genuinely not trolling. I have no idea what that is. What is this? I've heard this. Like I recognize the name. I don't know what it is though. Why is this? And who made this website in light mode too? That's the next big question. Come on, people. All right, here we go. My eyes. Okay, so these are top YC. Oh, we got Sam Altman here, classic Sam Altman. Let's see. Applications close at 8 p.m. Yeah. Is this AI stuff? I have no idea what this is. What is this? YC is run by startup founders who build exactly what they wanted when growing up. Like, what do they do though? What is YC? What is it about? Yeah, what is it? What happens? Okay. It's a 3-month program. Goal. Oh, help startup takes off. So this is like a... Okay, I get it. It's like a little hype cycle. Yeah. So you kind of like grinding on this, and everyone's in this together, and they get you in the right mindset, I guess. Yeah, and you get a little bit of money. Get a little bit of time together. Look at this. This is that's fun. Yeah, I don't know. Maybe this isn't for me. Who knows? this pure mind. You know, or maybe I'm just wasting my potential. Maybe I should apply for this. Get that $500,000 little startup fund. I'm not thinking big enough, right? Maybe. All right. I guess if I had a business idea, it would make sense. Hey, a raid, sick. I don't know who's raiding me, but all right, let's see. What do I need to do here? I need to fix some problems. I wanted to update my GitHub. Now that I have metal mostly working. Yeah, I'm still going. Not for too much longer though, probably. I have to go eat. I have to go run as well. I haven't done my exercise today. Exercise for a healthy mind, right? All right, let's see. Okay, so it doesn't know what this is. What is this? So, see, this is where I use AIs for stuff like this. because this is truly what I was after. I gotta do my my white space. There we go. Does this work across all of the compilers? That was the question. Oops. All right. You got a revelation. Yeah, thanks for stopping by, man. It was fun. I like the inspiration. You've inspired me. Inspired me to think big. A website, but projecting a 3D sphere. There you go. And then you move the sphere around. That would actually be kind of cool. It's like a world. You could do other shapes too, like a torus. I think a torus gives you more surface area while still looping around one of the axes, or both of the axes, I guess. Though I guess there's more distortion. A torus. Yeah, I don't know. All right, is this done publishing? Why is this taking so long? Man, this is taking forever. Why is this taking so long to upload? It might be. Which movie is that? I don't recognize the quote, but I'm also young, so. The Matrix. Okay, yeah, I haven't... Believe it or not, I haven't actually watched The Matrix yet. I don't know how that's possible, but I haven't seen it yet. All right. That's funny. I'm sorry. Obviously, I know what the Matrix is. Like, I'm not ignorant to the Matrix. I just haven't seen it. All right. Will this work first try? Let's find out. Hey, there we go. Look at that. Metal first try. All right. How much time do I have before I want to leave? Easy clap. So one thing I need to do still is I'm compiling, and maybe I'll do this before I end the stream tonight, so that way I can get in a pretty good spot. I'll need AI to help me on this though, probably, because I don't know how to do this. But right now I compile the shaders, so shader init. I compile the shaders here in the at the runtime, at runtime, which is kind of what you do with OpenGL. You compile the shader code at runtime. But for metal code, you're actually not supposed to do that because you need like the X tools installed on your computer in order to even do this. So you're supposed to compile this like at build time, at least into the bytecode representation. So I need to get this out of here basically. And let's see. I'll have a one-line commit here. So we need to think about how to do that. I guess the question is in here, runtime, shaders. Oops. So do I use device or anything here? I do use device. Of course I do. This is where I just go to ChatGPT and ask it how to do this offline. Offline shader compilation in metal. Instead of compiling metal shading languages, you source the runtime, you compile it ahead of time into a metal library file called a metal lib. Then load that binary directly at runtime. This avoids I can bring this over here. So what do we need to do? Using xrun. I don't want to call it though through the command line. This is literally not what I'm asking. Basically what I need to do is I'm compiling the shaders right now, the metal shaders at runtime, using this stuff, this new library with source, and then you like give it all the source code. And this is compiling the shader into a metal library, it's called. And then from that you have to get like the vertex program. Anyway, I'm doing this at runtime when the game starts up. So I'm storing the source code in like raw text in my binary file. But you're not actually supposed to do this. Like the Apple docs basically tell you shouldn't do this for a couple reasons. So I should be doing this at like build time and then storing just the library itself, like basically the output of this. I don't know why I have double semicolons. I should be storing this in my binary file, I guess. So I'm just trying to see if there's a way to do this. The annoying thing is that this requires a device here. So like, I guess it's not that annoying. Where do I initialize the device? You create a default system device. I guess I can create a super simple shader compiler thing in the yeah, they are. Well, it is. What happens is you take the source code, so like the raw text, metal shader language code. And what you're supposed to do is with metal is you're supposed to compile it to bytecode. Metal has like a metal bytecode, and then you store that in your binary file, or whatever. You ship that with your game, and then at game startup, the metal drivers will then take that bytecode and do like the final step of turning it into optimized, GPU specific, I guess, assembly. I don't know what else you'd call it. But right now I'm doing that entire step at runtime in the game. And that's like how OpenGL works, is you just ship the shader code with your game and then load it up. But like Vulkan works the way Metal, I just described for Metal, because you have SPIR-V, the SPIR-V bytecode. And DirectX has a similar thing as well. It's like DXL or something like that. I forget what the specific acronym is. So I can just create I can create a super simple layer in my build tool that does this. Unfortunately, this is MXL. I don't even know which of these I need. Which header do I need for this? Mm-hmm. So just like I need this header as well. Or these two. This is where you start vibe coding the metal shader language compiler. Because I'm lazy. All right, let's see. Does this look reasonable? All right. Okay, so this makes sense so far. We allocate a string, create a library device with library source. I feel that. We just got snow where I live for the first time of the year yesterday. And I'm starting to feel the draft coming off the windows. It hits my feet. All right, alloc data size. I mean, will this work? Who knows? I think this should be fine. So now we need to guard this so it doesn't actually compile if we are on Windows. Because I think right now this will just break because it doesn't know what this is. Or wait, no, it didn't. How's that possible? Yeah, it's not getting included. Okay, so in boot, we need to add that. Yeah, there we go. Let's see. Hey, how's it going? Welcome, welcome, welcome. Okay, so where should I plug this in then? It's kind of gross the way I'm doing this. But that's fine for now. We'll just start with the vertex and fragment shaders. So okay, so now that should store the binary data of the shader library in theory, and then at runtime it should just be a matter of doing shader init. It should be a matter of doing, let's see, let's just close some of this off at 0. Let's see. Okay, in theory this should just work. We'll see though, because I'm not sure why it wouldn't work, I guess. All right, let's get this committed. Okay, I didn't initialize. Ooh, yeah, that's a good call. Yeah, that's a great call, actually. Thanks for catching that. Good spot. And then in here, I didn't initialize this either. Where am I? Build. And what was this mat about? Undefined symbols. Oh, I need to link to metal as well. Ah, that's such a pain. That's right. So these are link rules. Let's see. I need to do this for DirectX as well. I'm actually not doing this in DirectX 2. Okay, what are we doing? Metal. Undefined symbols for architecture. Object release. Well, it's not mad about instance method, new serialized archive not found. Interesting. Okay. What is this mad about? This is so weird. All right, what's this problem? Undefined symbols. I think I'm just missing include somewhere. Need foundation as well. No such file or directory foundation. What? I don't have a space. Of course. Okay, here we go. We've actually gotten to the runtime, or the actual execution. So it doesn't like this. It doesn't like this function. I'm like fighting the AI right now over on the side. What's this mad about? I can call this dynamically? What? I don't think that solves my problem, but... Failed to serialize metal library. Why does this seem so convoluted? All right, I'm gonna try something else. So it seems like you're kind of forced to use this this XC run thing. It's like system call, which is really annoying because it's like gonna write a file and then I'm gonna have to load the file and then copy its data into my binary. Well, let me see this. This should work. Okay. Actually. What's happening? My remote desktop is failing me. What's happening? Stop. Get out of here. Okay, and hopefully this works. This actually might simplify stuff. I just wasn't hoping to have to do that. Hey, there we go. That worked. I don't like how long it takes the shaders to compile now, though, which is kind of unfortunate. But that's okay. If you're working on a Mac, you just accept it's not going to be fast. The nice thing is I can simplify this now. What is going on? All right, that is a good amount of progress today. I'm excited. Fixed the renderer, offline shader compilation, fixes to the shader language. Need to sync this.